December 26, 1944, 300 miles southeast of Tokyo Bay. A submarine surfaced in the pre-dawn darkness. But this was not a normal submarine. At 400 feet long and 39 feet wide, it was the largest submarine ever built. Displacement: 5,223 tons surfaced, 6,560 tons submerged. Nearly twice the size of the largest American fleet submarine. It carried a crew of 144 men, and mounted on its deck, inside a massive cylindrical hangar 115 feet long, were three ICM-6A Sarin floatplane bombers. Each aircraft carried an 1,800-pound bomb or torpedo.
This was the I-400, the Japanese Navy's most secret weapon. A submarine aircraft carrier designed for one purpose: to strike the American mainland. No other nation had built anything like it. The concept seemed impossible. A submarine had to be streamlined, hydrodynamic, designed to slip through water with minimal resistance. This vessel had a huge cylindrical hangar bolted to its deck. The engineering challenges were staggering, but Captain Tatsunoke Ariizumi stood on the conning tower that December morning and watched as his crew prepared to launch aircraft from a submerged submarine. The process would take exactly 45 minutes from surface to aircraft launch. Every second mattered. Surface operations made the I-400 vulnerable to American patrol aircraft. Ariizumi had timed this operation for pre-dawn specifically, dark enough to avoid visual detection, early enough to launch before sunrise. At 4:47 a.m., the deck crew emerged from the forward hatch, 20 men in synchronized motion. They moved to the hangar cylinder and began the unlocking sequence. The hangar door was not a simple hatch. It was a massive pressure-sealed door designed to withstand depths of 300 feet. 8 locking mechanisms. Each required precise rotation. The crew had practiced this procedure 47 times. They could do it in darkness. They could do it in rough seas. They had 12 minutes to open the hangar and extract the first aircraft. The hangar door swung open at 4:59 a.m. Inside the cylindrical chamber, 3 aircraft sat folded and compressed. Wings folded upward. Horizontal stabilizers folded downward. Floats detached and stored separately. Each aircraft had been designed specifically for this mission. The ICM-6A Sarin. Length 11.64 meters. Wingspan 12.26 meters. When folded, wingspan reduced to 4.58 meters. Maximum speed 295 miles per hour. Range 740 miles. Bomb load 1,800 pounds. The aircraft had been named Sarin, meaning mountain haze, a poetic name for a weapon designed to bring destruction to American cities. The first aircraft emerged from the hangar at 5:03 a.m. A hydraulic catapult system mounted on the submarine's deck would launch it, but first the aircraft had to be assembled. Wings extended and locked, horizontal stabilizers lowered and secured, floats attached to the fuselage, fuel tanks topped off, weapons loaded. The crew had 15 minutes per aircraft. Lieutenant Commander Akira Tsuboi was the lead pilot. He stood on the deck watching his aircraft being prepared. This was his 23rd training mission in the Sarin. He had logged 340 hours in the aircraft. He knew its capabilities. He knew its limitations. He knew that once he launched from this submarine, his chances of returning were approximately 40%. The mathematics of submarine aviation were brutal. Launch was relatively simple. Recovery was nearly impossible. The Sarin was designed as a float plane. It would land on water after completing its mission. The submarine would surface, recover the aircraft using a crane, fold it, and store it back in the hangar. In theory. In practice, the recovery operation took 87 minutes in calm seas. In combat conditions, with American patrol aircraft hunting for surfaced submarines, recovery was suicide. Tsuboi knew this. Every pilot knew this. They launched, knowing they would probably never return to the I-400. But that was acceptable. This was not a mission of return. This was a mission of impact. The I-400 and its sister submarines, the I-401 and I-402, represented Japan's final strategic weapon, a way to strike American territory when conventional naval forces had been destroyed, a way to demonstrate that Japan still had the capability to bring war to American soil. The psychological impact would be devastating. American cities bombed by aircraft launched from submarines that appeared and disappeared without warning. At least, that was the theory. Captain Ariazumi checked his watch. 5:18 a.m. The first aircraft was nearly ready. Tsuboi climbed into the cockpit. The engine, a 1,400 horsepower Aichi Atsuta 32, started on the first attempt. The sound was deafening in the pre-dawn silence, a roar that carried across the water for miles. Every second the engine ran increased the risk of detection. Ariazumi gave the signal. Launch. The catapult fired. Compressed air drove a piston that accelerated the Siren from 0 to 80 miles per hour in 60 feet. The aircraft shot off the deck, hung in the air for a moment, then climbed into the darkness. Tsuboi was airborne. The second aircraft was already being extracted from the hangar. The process repeated: assemble, fuel, arm, launch. At 5:34 a.m., the second Siren launched. At 5:49 a.m., the third. 3 aircraft in the air. Each carried enough explosive power to destroy a city block. Each pilot had orders to strike specific targets on the American mainland. But these were not those orders. This was December 26, 1944. This was a training exercise. The real mission, the one that would send these aircraft against American cities, was still being planned. The target was still being debated. Some in the Japanese Naval General Staff wanted to strike San Francisco. Others wanted to target the Panama Canal. Still others wanted to attack the locks at the Panama Canal's Pacific entrance, crippling American ability to move ships between oceans. Admiral Isoroku Yamamoto had originally conceived the I-400 program in 1942. He had envisioned a fleet of 18 submarine aircraft carriers, each capable of carrying 3 bombers. Together, they could launch 54 aircraft in a coordinated strike against American infrastructure. The psychological impact would force America to divert resources to homeland defense. It would demonstrate Japan's reach. It would prove that no American city was safe. But by December 1944, reality had crushed those ambitions. Japan had only completed 3 I-400 class submarines: the I-400, I-401, and I-402. A fourth, the I-404, was under construction but would never be completed. Material shortages, American bombing raids on Japanese shipyards, and the deteriorating war situation had destroyed the program's timeline. Instead of 18 submarines striking in 1943, Japan had 3 submarines training in late 1944, and the Americans had no idea they existed. Captain Ariazumi smiled at that thought. For all their intelligence superiority, for all their code-breaking capabilities, the Americans did not know about the I-400 class. The submarines had been built in secret at the Kure Naval Arsenal. Construction had begun in January 1943. The I-400 had been commissioned in December 1944, 23 months from keel laying to commissioning. Remarkable speed for such a complex vessel. The I-400 was not just large, it was revolutionary. The engineering solutions required to build a submarine aircraft carrier had pushed Japanese naval architecture to its limits. The fundamental problem was buoyancy and stability. A submarine had to maintain neutral buoyancy while submerged. Every component, every system, every piece of equipment had to be precisely calculated to ensure the vessel could dive and surface safely. Adding a massive aircraft hangar to the deck threw all those calculations into chaos. The hangar alone weighed 87 tons empty. With 3 aircraft inside, the weight increased to 142 tons. That weight was mounted high on the submarine's center of gravity, making the vessel top heavy and unstable. The solution required revolutionary ballast tank design. The I-400 had 8 separate ballast tanks, 4 main tanks along the hull, 4 trimming tanks positioned strategically to counterbalance the hangar weight. When the submarine prepared to dive, pumps filled the ballast tanks with seawater in a precisely timed sequence. The process took 90 seconds. If the timing was off by even 10 seconds, the submarine could become unstable and capsize. Lieutenant Yasuo Fujimori was the I-400's diving officer. He had trained for 14 months on this specific submarine. He knew the ballast system better than anyone. He had conducted 127 practice dives. He had experienced 3 near disasters when ballast pumps malfunctioned and the submarine nearly went into an uncontrolled dive. He had developed an instinct for the vessel's balance. He could feel when something was wrong milliseconds before instruments showed a problem. The aircraft had launched. Now came the dangerous part. Recovering the submarine's stability and diving before American patrol aircraft arrived. Ariazumi gave the order: clear the deck, secure for dive. The deck crew moved with practiced urgency, tools stowed, hatches secured. The hangar door closed and locked. 8 locking mechanisms rotated into place. Each lock had to seat perfectly. Any gap, any imperfect seal, and water pressure at depth would tear the door off its hinges. At 5:52 a.m., the deck was clear. Ariazumi descended into the conning tower. The bridge hatch sealed behind him. He moved to the control room where Fujimori waited at the diving station. Dive. Make depth 200 feet. Fujimori's hands moved across the ballast controls. Valves opened in sequence. Tank 1, Tank 2, Tank 3, Tank 4. Water rushed into the ballast tanks. The submarine's bow tilted downward. 5 degrees, 10 degrees, 15 degrees. The I-400 began its descent. The pressure hull groaned. Metal under stress. This was normal. The I-400 had a test depth of 330 feet. Its crush depth, the depth at which the pressure hull would catastrophically fail, was estimated at 450 feet. Fujimori watched the depth gauge. 50 feet, 100 feet, 150 feet. The descent rate slowed. The trimming tanks were doing their work, compensating for the hangar's weight. At 200 feet, the submarine leveled off. Fujimori allowed himself a breath. Another successful dive. But up on the surface, Lieutenant Commander Tsuboi was having problems. His Seiran had developed an oil leak. Pressure gauge on the engine showed fluctuating oil levels. Not critical yet, but concerning. He had 20 minutes of flight time remaining before he had to return to the rendezvous point where the I-400 would surface for recovery. But with an oil leak, returning might not be an option. If the engine failed, he would have to ditch in the open ocean. At night, in December. Water temperature 58 degrees Fahrenheit. Survival time in water that cold, approximately 3 hours if he avoided hypothermia. But he was 300 miles from land. No rescue would reach him in time. This was the reality of submarine aviation. High risk, low margin for error. Every flight was potentially fatal. Tsuboi checked his instruments. Oil pressure holding, engine temperature normal. He would continue the training mission. He had orders to fly a specific patrol pattern, simulating a strike approach on an American convoy. He would complete the mission. Then he would decide whether to attempt recovery or ditch the aircraft. Back aboard the I-400, Captain Ariazumi reviewed the training schedule. 3 more days of aircraft launch drills. Then the submarine would return to Kure Naval Base for final preparations. The real mission, Operation Hikari, Mountain of Light, was scheduled for February 1945. The target had finally been selected. Not San Francisco, not the Panama Canal. The target was Ulithi Atoll in the Caroline Islands. Ulithi was the largest American forward anchorage in the Pacific. Over 600 American warships used Ulithi as a staging point for operations against Japan. Aircraft carriers, battleships, cruisers, destroyers, supply ships, all concentrated in one location. The Japanese Naval General Staff had calculated that a successful strike on Ulithi could destroy or damage 20 to 30 American capital ships. The psychological and strategic impact would be enormous. The plan was simple in concept, nearly impossible in execution. The I-400 and I-401 would approach Ulithi submerged. They would surface at night, 200 miles from the atoll. They would launch 6 aircraft total, 3 from each submarine. The aircraft would fly in low, under American radar coverage. They would attack at dawn, when visibility was good, but before combat air patrols were fully deployed. Each aircraft would target a specific ship type. Aircraft carriers were priority 1, battleships priority 2. The aircraft would either bomb their targets or, if critically damaged, crash into them in a kamikaze attack. After the strike, any surviving aircraft would attempt to return to a rendezvous point 300 miles from Ulithi. The submarines would surface and attempt recovery, but everyone involved understood this was optimistic. The likely outcome was that all 6 aircraft and their crews would be lost. But if they destroyed even 5 American capital ships, the trade would be worth it. 6 aircrew and 2 submarines, expendable. 5 aircraft carriers or battleships, irreplaceable. Ariazumi understood the mathematics. He did not like them, but he understood them. This was December 1944. Japan was losing the war. The combined fleet had been destroyed at Leyte Gulf. The Philippines were falling. American B-29 bombers were beginning to strike Japanese cities. The war was entering its final phase. Conventional operations had failed. Japan's only remaining option was asymmetric warfare. Weapons and tactics the Americans did not expect. Submarines that launched aircraft, kamikaze attacks, human torpedoes, suicide boats. Desperate measures for a desperate situation. But the I-400 represented something more than desperation. It represented innovation. The engineering that created this submarine was extraordinary. Consider the technical challenges. A standard fleet submarine like the American Gato class was 311 feet long, displaced 1,525 tons surfaced, carried a crew of 60, and could dive to 300 feet. The I-400 was 400 feet long, displaced 5,223 tons surfaced, carried a crew of 144, could dive to 330 feet, and somehow maintain stability despite having a massive hangar mounted on its deck. The designers at the Kure Naval Arsenal had solved problems that American and British naval architects considered unsolvable. The primary challenge was hydrodynamics. A submarine had to move through water efficiently. Every protrusion, every non-streamlined surface created drag that reduced speed and increased power consumption. The I-400's hangar was the least hydrodynamic structure imaginable. A 115-foot-long cylinder mounted on the deck. It created enormous drag. The submarine's maximum speed suffered because of it. Surfaced, the I-400 could make 18.7 knots. Submerged, only 6.5 knots. By comparison, an American Gato-class submarine could make 20 knots surfaced and 9 knots submerged. The I-400 was slower, both surfaced and submerged. This made it vulnerable. Speed was survival for a submarine, the ability to outrun depth charges, to escape patrol aircraft, to reposition quickly. The I-400 sacrificed speed for capability. It was a trade-off the designers accepted. The second challenge was structural strength. The hangar had to withstand water pressure at depth. The cylindrical design helped. A cylinder distributes pressure evenly across its surface. But the hangar door was a weak point. It was flat, not curved. Pressure concentrated on it. The door was constructed of reinforced steel, 12 millimeters thick with internal bracing. It could withstand pressure up to 400 feet depth, but it was heavy, 4.7 tons. Opening and closing that door manually was impossible. The submarine used a hydraulic system powered by compressed air. The third challenge was the catapult. Launching an 11-meter, 3.5-ton aircraft from a submarine deck required enormous force. The catapult used compressed air. The submarine carried 12 air tanks, each pressurized to 3,000 pounds per square inch. When the catapult fired, compressed air drove a piston along a 60-foot track. The piston accelerated the aircraft to 80 miles per hour in 1.2 seconds. The G-forces were brutal. Pilots experienced 4.5 Gs during launch, but it worked. The system could launch 3 aircraft in 30 minutes under ideal conditions. The fourth challenge was aircraft storage. 3 aircraft plus spare parts, plus ammunition, plus aviation fuel. All had to fit inside a 115-foot hangar, with a 12-foot internal diameter. The solution was folding. The Submarine could be folded into a package 4.58 meters wide and 3.5 meters tall. Wings folded up, tail folded down, floats detached, landing gear retracted. In this configuration, 3 aircraft fit inside the hangar with less than 1 meter of clearance between them. The folding mechanism was complex, 37 different locking points per aircraft. Each had to be secured properly, or the aircraft would not unfold correctly. Assembly errors were potentially fatal. The 5th challenge was crew management. 144 men in a submarine designed for long-range patrols. The I-400 was designed to operate for 90 days without resupply. That meant carrying food, water, fuel, ammunition, spare parts, and everything else needed to keep the submarine and aircraft operational for 3 months. The interior was cramped beyond belief. Crew berthing was minimal. Most sailors slept in bunks stacked 3 high with less than 18 inches of clearance. Officers had slightly better accommodations, but nothing luxurious. The crew was divided into sections: submarine operations crew, 89 men, aviation crew, 24 men, aircraft maintenance crew, 12 men, pilots and air crew, 9 men, command staff, 10 men. Each section had specific responsibilities. The submarine operations crew handled navigation, engineering, weapons, communications. The aviation crew maintained the aircraft, operated the hangar, ran the catapult system. The aircraft maintenance crew performed repairs, handled spare parts, managed aviation fuel. The pilots and aircrew flew the missions. The command staff planned operations, coordinated with Naval General Staff, made tactical decisions. Living conditions were harsh. Temperature inside the submarine ranged from 85 to 105 degrees Fahrenheit depending on depth and location. The engineering spaces were hotter, sometimes reaching 120 degrees. Humidity was constant. Condensation formed on every metal surface. Mold grew everywhere. Fresh water was rationed. Each crew member received 3 liters per day for drinking, washing, and cooking. Bathing was weekly at best. The submarine smelled of diesel fuel, human sweat, cooking oil, and stale air. Recycled air. The atmosphere processing system could only do so much. Carbon dioxide built up over time. By week 4 of a patrol, breathing felt labored. By week 8, everyone suffered headaches and fatigue. But the crew endured because they believed in the mission. They believed the I-400 could change the war's outcome. They believed that striking American targets would force negotiations. They believed in victory through technological superiority. And they had reason to believe. The I-400 represented the most advanced submarine technology in the world. The Americans had nothing comparable. The British had nothing comparable. The Germans had experimented with submarine-launched aircraft in the 1930s, but abandoned the concept. Only Japan had built a functional submarine aircraft carrier. Lieutenant Commander Tsuboi completed his training patrol and returned to the recovery rendezvous point. It was now 6:47 a.m. Dawn was breaking, visibility improving. Tsuboi circled at 2,000 feet, watching for the I-400 to surface. His oil leak had stabilized. Engine temperature was holding. He would attempt recovery. At 6:52 a.m., the submarine surfaced 400 meters away. Tsuboi descended, configured the sea run for water landing, and touched down at 6:55 a.m. The aircraft settled onto its floats. He taxied toward the submarine. Recovery operations began immediately. The I-4's crane extended. A hook descended toward the Submarine. Tsuboi climbed out of the cockpit onto the float. He attached the hook to the aircraft's lifting point. The crane lifted. The Submarine rose out of the water, dripping seawater, swinging slightly in the morning breeze. It rotated over the submarine's deck and lowered toward the hangar opening. Deck crew guided it into position. The aircraft folded, compressed, and disappeared into the cylindrical hangar. Tsuboi climbed aboard the submarine. The entire recovery operation took 53 minutes. Fast, but not fast enough for combat conditions. In combat, the submarine would be under constant threat. Every minute on the surface was a minute of vulnerability. The second and third aircraft recovered successfully. By 8:03 a.m., all 3 sirens were stored in the hangar. The submarine dove to 200 feet and set course for Cure. The training exercise was complete. Captain Ariazumi reviewed the results with his officers. Launch timing, acceptable. Aircraft performance, acceptable. Recovery operations, too slow but improving. Overall assessment, the crew was ready for combat operations. But Ariazumi had concerns. The oil leak in Tsuboi's aircraft indicated maintenance issues. The Seirin was a new aircraft, still experiencing developmental problems. Engine reliability was questionable. The Aichi Atsuda 32 engine was powerful but temperamental. It required precise maintenance, specific fuel grades, careful monitoring. In combat conditions, with limited maintenance facilities and time pressure, engine failures were probable. Ariazumi estimated that of 6 aircraft launched in an attack, perhaps 4 would reach the target. The other 2 would fail mechanically or be shot down by American defenses. The numbers were grim, but acceptable. 4 aircraft striking Ulithi, each carrying 1,800 pounds of explosives. If each aircraft hit a capital ship, the damage would be significant. 2 aircraft carriers damaged or sunk would represent 200 aircraft removed from American combat operations. 2 battleships damaged or sunk would remove massive firepower from the fleet. The strategic impact would justify the cost. The I-400 arrived at Cure on December 29, 1944. The submarine entered dry dock for maintenance and final preparations. Technicians swarmed over the vessel, checking systems, replacing worn components, loading supplies. The I-401 was already in dock, undergoing similar preparations. Both submarines would deploy together for Operation Hikari. Launch date, February 10, 1945. But on January 1, 1945, everything changed. American intelligence intercepted Japanese communications regarding submarine operations in the Caroline Islands. The intercepts were fragmentary, encoded, but they contained enough information to alert American commanders that Japan was planning a major submarine operation. Admiral Chester Nimitz, Commander-in-Chief Pacific Fleet, ordered increased submarine patrols around Ulithi. Additional radar coverage, more frequent air patrols. The security around Ulithi tightened significantly. Japanese naval intelligence detected the increased American activity. They reported it to the Naval General Staff. A debate erupted. Some officers wanted to proceed with Operation Hikari despite increased American vigilance. Others wanted to delay until American attention shifted elsewhere. Still others wanted to cancel the operation entirely and save the I-400 class submarines for a different mission. Admiral Somu Toyota, commander of the combined fleet, made the decision. Operation Hikari would proceed, but with modifications. The target changed from Ulithi to the Panama Canal. The new mission, Operation Arashi, Storm, would strike the canal locks on the Pacific side. Destroying those locks would prevent American ships from transiting between oceans. It would force the Americans to route ships around South America, adding weeks to transit times. The strategic impact would be enormous. Captain Ariazumi received the new orders on January 15, 1945. He studied the mission profile. The I-400 and I-401 would cross the Pacific submerged, maintaining depth during daylight hours, surfacing only at night to recharge batteries and refresh air. The voyage would take approximately 35 days. They would approach the Panama Canal from the west, surface 200 miles offshore, launch 6 aircraft, and attack the Gatun locks on the Pacific side. The operational challenges were staggering. The voyage to Panama was over 6,000 nautical miles. The I-400 had a range of 37,500 nautical miles at 14 knots surfaced. But submerged, running on battery power, the range dropped to 60 nautical miles at 3 knots. The submarine would have to surface regularly to run diesel engines and recharge batteries. Each surface period was a vulnerability. American patrol aircraft operated throughout the Pacific. Detection meant death. The I-40's sensor suite included radar, but it was primitive compared to American systems. The Type 22 surface search radar had an effective range of 10 miles in good conditions. American aircraft radar could detect a surfaced submarine at 30 miles. The I-400 would be detected long before it detected the threat. Survival depended on surfacing in areas with low American patrol activity, charging batteries as quickly as possible, and diving before detection. The crew began final preparations: food loading, fuel loading, ammunition loading, spare parts loading. Every available space in the submarine was packed with supplies. The crew calculated that they would need 127 tons of diesel fuel for the voyage to Panama and return, 18 tons of aviation fuel for the Siran aircraft, 42 tons of food and fresh water, 8 tons of spare parts, 14 tons of ammunition for both submarine torpedoes and aircraft weapons. The I-400 was loaded to maximum capacity. Every additional kilogram affected the submarine's trim and stability. On February 10, 1945, the I-400 and I-401 departed Kure Naval Base. They submerged immediately and set course east. The submarines traveled independently, maintaining radio silence. Communication was strictly controlled. They would only transmit under emergency circumstances. American direction-finding equipment could locate a transmitting submarine within minutes. Silence was survival. The first week passed without incident. The submarines maintained depth during daylight, surfaced at night, ran diesel engines for 4 hours to recharge batteries, then dove before dawn. The routine was exhausting. The crew worked in shifts. Sleep was minimal. Everyone was constantly alert for threats. On February 18th, the I-400 detected an American patrol aircraft on radar. Distance 28 miles. Approaching. Captain Ariazumi made an instant decision. Emergency dive. Maximum speed. The klaxon sounded. The crew scrambled to diving stations. Ballast tanks flooded. The submarine's nose pitched downward. 10 degrees, 20 degrees, 30 degrees. The descent was violent. Men grabbed railings to avoid being thrown across compartments. Equipment broke loose and crashed against bulkheads. The submarine reached 300 feet in 78 seconds. Ariazumi ordered all engines stopped. Silent running. The crew froze. No unnecessary movement. No unnecessary sound. Sound traveled far underwater. American destroyers and patrol aircraft carried sonobuoys, devices that listened for submarine noise. One dropped engine part, one slammed hatch, one careless footstep could betray their position. They waited in silence. 5 minutes, 10 minutes, 15 minutes. The sound operator listened on hydrophones, monitoring for surface activity. He heard nothing. 20 minutes. Still nothing. At 30 minutes, Ariazumi authorized slow movement. The aircraft had passed. They had not been detected, but the encounter was a warning. American patrols were more extensive than expected. The I-4's route crossed multiple patrol zones. They would have to be more careful. Surface time would have to be minimized. Battery recharging would have to be faster. The margin for error was razor thin. On March 2nd, the I-400 crossed the international date line. They were now approximately 3,200 nautical miles from Kure, 2,800 miles from Panama. The voyage was half complete, but the submarine was experiencing problems. The port diesel engine was running rough. Engine temperatures were elevated. The chief engineer, Lieutenant Saburo Kusaka, diagnosed the problem as carbon buildup in the fuel injectors. The engine needed maintenance, but performing maintenance while submerged was impossible. They would have to surface and spend extra time on repairs. On the night of March 5th, the I-400 surfaced in a remote area of the Pacific. Weather conditions were poor. Heavy seas, 30-knot winds. Visibility under 1 mile. Perfect conditions for surface maintenance. Poor visibility meant low probability of aircraft detection. The deck crew emerged and began engine repairs. But working in heavy seas was dangerous. Waves crashed over the deck. Men had to secure themselves with safety lines to avoid being washed overboard. Lieutenant Kusaka and his engineering team worked on the diesel engine. They removed the fuel injector assemblies, cleaned carbon deposits, tested fuel flow, reinstalled components. The work took 3 hours, 3 hours of surface vulnerability, but when the engine restarted, it ran smoothly. Temperature normalized. Power output returned to specifications. The maintenance was successful. The submarine dove at 3:47 a.m. Another crisis averted. But the crew was exhausted. The stress of constant vigilance, the physical demands of operating in a confined space, the psychological pressure of knowing that one mistake meant death for everyone aboard. Morale was declining. Captain Ariazumi knew this. He also knew there was nothing he could do about it. The mission continued. On March 12th, the I-400 was approximately 1,200 nautical miles from the Panama Canal. They were entering the most dangerous phase of the voyage. American military presence in the Caribbean and Central America was heavy. Patrol aircraft flew constant missions. Surface ships patrolled shipping lanes. The probability of detection increased dramatically. Ariazumi changed tactics. The submarine would remain submerged for longer periods. Battery recharging would occur only when absolutely necessary. Speed would be reduced to conserve power. They would move slowly, carefully, like a predator stalking prey. The crew understood. This was the final approach. In 10 days, they would be in position to launch the attack. But on March 15th, everything changed again. A message came through from Naval General Staff. Ultra-low frequency transmission, barely detectable, but authenticated and clear. Operation Arashi was canceled. The I-400 and I-401 were ordered to return to Japan immediately. The mission was terminated. Captain Ariazumi read the message 3 times. He could not believe it. 40 days at sea. Over 5,000 nautical miles traveled. The most technologically advanced submarine in the world, within striking distance of a strategic target, and the mission was canceled. He demanded explanation. None was provided. Orders were orders. The reason for the cancellation would not become clear until after the war. American intelligence had broken additional Japanese codes. They had intercepted communications about submarine operations near Panama. The Americans had deployed additional defenses around the canal. Radar coverage had been increased. Air patrols had been intensified. The Naval General Staff had concluded that the mission's probability of success had dropped below acceptable levels. Sending the I-400 and I-401 into a heavily defended area, where they would almost certainly be detected and destroyed, was not worth the minimal damage they might inflict. The submarines turned around and began the long voyage back to Japan. But the world situation had changed dramatically during their absence. On April 1st, American forces invaded Okinawa. On April 7th, the battleship Yamato was sunk in a suicide mission. On April 12th, President Franklin Roosevelt died. On April 30th, Adolf Hitler committed suicide in Berlin. Germany was collapsing. Japan was next. The I-400 reached Japanese waters on April 20th, 1945. They did not return to Kure. American B-29 bombers had destroyed much of the naval base. Instead, they proceeded to Maizuru Naval Base on the Sea of Japan coast. The submarine docked on April 22nd. The crew disembarked. They had been at sea for 71 days. They had traveled over 12,000 nautical miles. They had completed 0 combat missions. Captain Ariazumi met with Admiral Toyota on April 25th. The meeting was brief. Japan was losing the war. The combined fleet no longer existed. American submarines had destroyed Japanese merchant shipping. The home islands were under blockade. Food was scarce. Fuel was scarce. Ammunition was scarce. The war would be over soon. But Admiral Toyota had one final mission for the I-400 and I-401. Operation Hikari was reactivated. The target returned to Ulithi Atoll. But this would not be a strike mission. This would be a reconnaissance mission. The submarines would approach Ulithi, launch aircraft, photograph American fleet dispositions, and return. The intelligence gathered would help the Naval General Staff plan final defensive operations. It was not a glorious mission. It would not change the war's outcome, but it would provide valuable information. Captain Ariazumi accepted the mission without comment. He understood that this was likely the I-400's final operation. Japan had perhaps 2 months remaining, 3 at most. American forces were preparing for an invasion of the home islands. When that invasion came, every Japanese military asset would be thrown into the defense, submarines included. The I-400 would probably end its service in some desperate last stand, firing its final torpedoes at American landing craft, then scuttling to avoid capture. But for now, there was one more mission: reconnaissance of Ulithi. Departure date: July 10, 1945. The I-400 spent 2 months in.